In today's lab, we'll be studying Kirchhoff's laws. Kirchhoff's current law says that the sum of the currents flowing into any node must equal the sum of the currents flowing out of that node. Kirchhoff's voltage law says that the sum of the voltage drops or differences going around any closed loop in a circuit must always be zero. And on the surface, this one sounds fairly simple, but in practice, if you're trying to analyze a circuit or if you're trying to measure a circuit, it can actually be quite difficult and confusing. Often students are confused about whether the voltage difference across some circuit element should increase or decrease. But I found two ways to make it just a little bit easier. For batteries, it's fairly straightforward. Those ones are labeled with positive and negative. So if you're going from negative to positive, it's a voltage increase. And if you're going from positive to negative, it's a voltage decrease. For resistors, it's a little bit more confusing. In that case, I like to focus on the direction that current is flowing. Or if you don't know the direction of current, then just assume a direction. You could just make it up. And in that case, if you're going in the direction of current across the resistor, then it's going to be a voltage decrease. You're going to lose voltage as you cross the resistor. And if you go against the current, if you're going across the resistor in the opposite direction that current is flowing, then in that case, it's a voltage increase. Later when we do this with the multimeter, I'll show you an easy way to make sure that we always know whether it's positive or negative, whether it's an increase or a decrease. First thing before we can build our circuit is we need to find the resistors. And for this lab, we need three resistors. We need the 3 kilo ohm, 4.3 kilo ohm, and 5.1 kilo ohm resistors. I explained in the previous labs how we can identify our resistors from their color codes. So the ones we're looking for today are orange, black, red. That one is our 3 kilo ohm resistor, and it also has the gold tolerance band of plus or minus 5%. Then 4.3 kilo ohms is yellow, orange, red, and that also has the gold tolerance. And then green, brown, red is the 5.1 kilo ohm. So again, 3 kilo ohm, orange, black, red with gold, and then 4.3 kilo ohms is yellow, orange, red, and then 5.1 kilo ohms is green, brown, and red. And each one of these three has the gold tolerance band of plus or minus 5%. Now we need to measure our resistors. So for this, just grab your multimeter, and as usual, let's make sure that the probes are in the correct ports. So we want black in comm and red in ohms, so look for the omega symbol. And these ones are going to be in the 20 kilo ohm range. 2000 ohms is going to be too low, so we want 20 kilo ohms. So we're going to do these measurements in the breadboard and put each end of the resistor in separate rows, and then touch the multimeter probes to either side of the resistor. And it looks like I've got 2.93 or 2.92 kilo ohms, so this is the 3 kilo ohm resistor, and the measured value is 2.92, which is the value that we'll use then for this experiment. And we'll do the same thing for the other two resistors. So this is now the 4.3 kilo ohm resistor. Again, I'm going to insert each end into a separate row and touch the multimeter probes to either side of the resistor. And we have 4.25 kilo ohms. That one is our 4.3, and we have 4.25 as the measured value. And we have the 5.1 kilo ohm resistor. Insert that in the breadboard. Touch the multimeter probes to either side of the resistor. And we have 4.99 kilo ohms. So that one is our measured resistance for the 5.1 kilo ohm resistor. Next, we need the voltage of two 9-volt batteries. So we need two 9 volts for the circuit, and we need to know the voltages of each one separately. So we need to keep track of which one is which, because they'll probably differ from each other just a little bit. So again, we need the multimeter for this, and let's check the probes real quick. Black in COM and red in V for volts. Then turn the dial to the 20 volt range, and we'll touch the probes to the battery terminals. Black on the negative, red on the positive. And this battery is 9.15 volts, so I need to keep track of which one this one is. This is 9.15, and I'll set that aside and record the value. Then we'll do the same thing for the other battery, and this one has 9.65 volts. So this one will be my second battery, 9.65, and I'll record that battery voltage as well. Again, with this lab, I need to warn you, whenever you measure battery voltage, make sure that the multimeter dial is actually set to measure voltage and not current. If you accidentally set it to current and then try to measure across the battery terminals, it's going to cause a huge amount of current to flow through the multimeter, and it will blow the internal fuse. So just be careful about that. Whenever you measure the voltage, always set it to measure voltage and not current. Now that we've made those measurements, we can go ahead and assemble our circuit on the breadboard. And I know this may be difficult to show on the camera, so I'm just going to go ahead and assemble it, and then I'll show you it afterwards. Okay, so now I've built the circuit, and let me briefly show you how it's laid out. So we've got our three resistors. We've got the 3 kilo ohm resistor, 4.3 kilo ohm, and 5.1 kilo ohm resistors. And each end of those is in a separate row on opposite sides of the breadboard. Then we've got the two batteries, which I've labeled as V source 1 and V source 2. And those are going from negative to positive across this gap here. So the black wire there is the negative, and that's connecting to the top of the 3 kilo ohm resistor. And then the red wire from V source 1 is going to the top of the 4.3 kilo ohm resistor. Then V source 2, we've got the black negative wire going to the top of 4.3 kilo ohms, and then the red positive wire going to the top of the 5.1 kilo ohm resistor. Then at the bottom, we've got these three jumper wires that connect the resistors into this blue power rail at the bottom of the breadboard. And the reason we need these is so we can remove the jumper wire and replace it with the multimeter, which will allow us to easily measure the current flowing through each resistor. Now we need to measure the voltages going around each of the three loops in our circuit. So we have the first loop here going through the 3K resistor, the first battery, and the 4.3K resistor. Then the second loop is going through the 4.3K resistor, the second battery, and the 5.1K resistor. And then the third loop goes around the outside. So it goes through the 3K resistor, the first battery, second battery, and the 5.1 kilo ohm resistor. So it goes around the outside like that. So we've got loop 1, loop 2, and then loop 3. So when we measure these voltages, the way to make sure that we always get the polarity correct, whether it's an increase or a decrease, a positive or negative voltage across some circuit element, is to always put the probes down in the same way. So let's start with the negative probe. So we'll put that on this side. We're going to go around this first loop. So we've got the negative probe down, and we put the positive one down. So we're going across the 3K resistor, and we have negative 7.51 volts. So we'll just record that, and that was going this direction across that resistor. Then we'll do the same thing for the battery. So we've got the negative first, and then the positive going in that direction around the loop. And we've got 9.07 volts. Then the last voltage for this loop, we put the negative down first again, and then the positive. So we're going through that resistor, going around the loop, and we have negative 1.52 volts. And that gives us the three voltages going around this first loop. So we had the first one, we went like this, negative and then positive across the 3K resistor. Then across the battery, we do the same thing. So we do it just like that. And then the last one, again, start with the negative, end with the positive, going through the 4.3K resistor. We get each one of those voltages, and that should sum to 0 according to Kirchhoff's voltage law. Now we can do the same thing for loop 2. So again, we start with the negative probe, then do the positive, and that gives us our first voltage, then negative and positive across the second battery, that gives us our second voltage, and then negative and positive going across the last resistor, that's the 5.1K resistor, and that gives us our last voltage. So again, 3 voltages for that second loop. Then we can do the same thing for the third loop. So just like we started on the first one, go across the 3K resistor, negative and then positive, then across the first battery, negative and positive, then across the second battery, negative and positive, and across the 5.1 kilo ohm resistor, just like that, negative and then positive. So that gives us all the voltages we need to test Kirchhoff's voltage law, and now we can go on and measure the currents. To measure the currents, we again need to check the multimeter. So let's make sure the probes are in the correct spots. We've got black in comm and red in milliamps, so that one looks good. And then to measure current, we want to start on the 200 milliamp range. So again, we want DC current and 200 M. We'll probably get down to the 20 milliamp range, but let's start on the 200 milliamp range, and then we can dial it down if we need to. So we've got three currents in the circuit. We've got I1 flowing through the first resistor, I2 flowing through the second resistor, and I3 flowing through the third resistor. To measure the first current, we'll remove the jumper wire below the 3 kilo ohm resistor, and then put the positive probe at the bottom of the 3K resistor and the negative probe at the bottom of either the 4.3K resistor or the 5.1K resistor. So that gives us our first current, and we have negative 2.5, negative 2.4 milliamps. And that is a lot less than the 20 milliamps, so we can dial it down to that range. And let me just measure it again. So again, positive there and then negative here, and we've got negative 2.55 milliamps. So that's I1, and I'll record that value. Then I need to replace that first jumper wire, and we'll then remove the second jumper wire below the 4.3K resistor. Then we'll do the same thing, put the positive probe at the bottom of the 4.3K resistor and the negative probe at the bottom of either one of the other resistors. This gives us 0.35 milliamps, so that would be I2. Then again, we'll replace that jumper wire and then remove the final jumper wire below the 5.1 kilo ohm resistor. We could do the same thing now to measure our third current. So we put the positive probe at the bottom of the 5.1 kilo ohm resistor and the negative probe at the bottom of either one of the other resistors, and that gives us the final current. Of course, your currents will be different than what I got because your resistors and your batteries will have slightly different values than what mine do. Then when you're done, just unplug the batteries. We don't want to consume power when we're not using them. And also turn off your multimeter. We don't want to waste the battery on that, so just manually turn it to off. And that's it for this experiment. So before we finish, I just want to give you a quick warning. This lab does have the potential to damage your multimeter, to blow the fuse. A lot of students in the past have made those mistakes and they've damaged their multimeter in the process. So just follow the instructions carefully. They will have more information than what is shared in the video. And good luck on your experiment.